Assalamualaikum and hi, we are from Group C. We'd like to present mathematical programming SEL assignment. So our team member consists of 6 people, which is Nur Fazlina, me, Farah Rehana, Alif Aiman, Jamshay, Izahana and also Amira. So without further ado, let's continue with question number 1.
My name is Nur Fazlina binti Muhammad. My metric number is 216075. So today I will present SEL assignment for question 1. Lorenzo manufactures 2 kinds of chair, one model TX and another GX model. Each TX model requires 6 minutes of assembly and 2 minutes of finishing, while the assembly of a GX model takes 10 minutes at the assembly department and 4 minutes of finishing at the finishing department. Each model of chair goes through 4 minutes of quality control. There are 4 machines at the assembly department and each will operate for 45 minutes per hour. The finishing department is staffed by 4 people, while 2 members of staff are located in the quality control department. A survey done at the factory showed that each member of staff needs a rest of 10 minutes per hour of work. Each TX model chair brings in a profit of 50 ringgit and each GX model chair earns a profit of 60 ringgit. Find and compare the optimal production quantity of each model. Okay. From the question 1, we can know the decision variable is X, number of TX model chairs produced, Y, number of GX model chairs produced, and then the objective function is maximize the profit. So max Z equal to 50X plus 60Y, and the constraint for the first assembly department, 6x plus 10y less than or equal 180, and finishing department 2x plus 4y less than or equal to 100, and the last one, quality control department, 4x plus 4y less than or equal 100, and the sign restriction is x and y greater and equal to 0. So for question 1, I'm using C programming to get the solution. So for the line 1, includes the standard input or output library to enable functions like printf. And then for line 2, line 3 marks the beginning of the main function where the program starts executing. And then for lines 4 until line 6, declares x and y as floating point variables for the number of TX and GX chairs. Initialize max profit to 0 to store the highest profit found. And then base underscore x and base underscore y will store the values of x and y that yield the best profit. And then for the line 8, a comment explaining that the program will test values of x and y from 0 to 100 in 0.5 increments. And then for the line 9, starts a loop for x from 0 to 100, increasing by 0.5 each time. And then for line 10, nested loop for y, also from 0 to 100 in 0.5 steps, allowing all combination of x and y. And then the line 11 until 13 calculates total minutes used in assembly department, 6 minutes per TX, 10 per GX, and for finishing department 2 minutes per TX, 4 per GX, and the last one, quality control, 4 minutes per unit, simplified as x plus y less than or equal 25. And then for line 15, checks if the current values of x and y satisfy all constraints. And then the line 16 calculates the profit for the current combination of x and y. And line 17 and until 20, if this profit is greater than the current max, store the new profit and update the base x and y. And line 26 until 28 prints the final result: optimal number of TXs, optimal number of GXs, maximum profit. I put 1 decimal place and 2 decimal places. And the last one is line 30. Ends the program and return 0 to indicate successful completion. Okay, from C programming to solve the question 1, I get the output, which is optimal TX X is 17.5 and optimal for GX is 7.5 and the maximum profit is 1,325 ringgit. So the output is same with the Excel solver I get. I will explain next. So for question 1, I use Excel solver to solve this question. From the data I get, I transfer the data to Excel and I get the value of Z is 1,325 and value of X is 17.5 and Y 7.5. Okay, from the Excel solver, I also get the answer report like this one. Okay, so this is the sensitivity report from Excel solver for question 1. And this one is the limits report from Excel solver for question 1. So, I can conclude that optimal solution for TX chess is 17.5 units, the GX chess is 7.5 units, and the maximum profit for this question is 1,325 ringgit. So, I can compare each model, which is the TX model is produced in higher quantity because it requires less time in the assembly and finishing departments compared to the GX model, making it more coefficient under the available resource constraint. Although the GX model offers a higher profit per unit, which is 60 ringgit compared to 50 ringgit for the TX, it consumes significantly more processing time, especially in the assembly and the finishing department, which are limited to 180 and 200 minutes respectively. Additionally, both models require the same amount of time in quality control, which is also a limiting factor. As a result, a larger proportion of TX chess allows for better utilization of the limited resources, leading to a more optimal production mix that maximizes overall profit. That's all from me. Thank you.
So I'm going to continue with question number 2. So the question is, Encik Ahmad has 2 farms that grow potato and yam. Because of different soil condition, there are differences in the yields and cost of growing crops on the 2 farms. So the yield and cost are shown in the table below. So each farm has 100 acre available for cultivation, 11,000 kgs of potato and 7,000 kgs of yam must be grown. Determine a planting plan that will minimize the cost of meeting these demands. So based on this table, we have farm 1 and farm 2, where the yam in the kg for farm 1 is 500, farm 2 is 650. Cost of the yam for farm 1 is 100 and cost of yam for farm 2 is 120. For potato, in farm 1 we have 400 kg, for farm 2 we have 350 kg, and the cost for potato for farm 1 is 90 and farm 2 is 80 ringgit. Okay, so from the question, the decision variable that we can get is x1 equal to acre of yam planted on farm 1, x2 is acre of yam planted on farm 2, y1 is equal to acre of potato planted on farm 1, Y2 acre of potato planted on farm 2. And for the objective function, since the question asks us to find the minimized cost of the meeting demands, so we get that min z equal to 100 x1 plus 120 x2 plus 90 y1 plus 80 y2. Okay, so the constraints consists of land that available, since the question say that each farm has 100 acre available for cultivation. So that's why for constraint we have farm 1 equal to x1 plus y1 less than 100, and farm 2 x2 plus y2 less than 100. So the requirement is it says from the question, it says that there are 11,000 kgs of potato and 7,000 kgs of yam must be grown. So for the constraint, we get that potato equal to 400 y1 plus 350 y2 more than equal 11,000 kgs, and yam is 500 x1 plus 650 x2 more than equal 7,000. Okay, so for the sign restriction, it's just same s1, s2, y1, y2 more than equal to 0. For question number 2, I use Python coding to solve this problem, where I use Python in Google Colab to solve this problem. So in line 1, I need to install a pub, where pub is like a Python library used for linear programming, and import it as a P to make it like easier in coding, like to refer in coding. And then in line number 3, I use LP minimize to tells the program that we need to minimize the objective function. And then line 5 until 8 is just like define decision variable, where the decision variable represent like how many acre to plant on each farm, where S1 is equal to yam on farm 1, S2 is equal to yam on farm 2, Y1 is equal to potato on farm 1, and Y2 is potato on farm 2. And then like each variable must be more than equal to 0. In line 10, it's just like objective function, where we want to find the minimized cost, where the total cost is equal to 100 times to the yam on farm 1 plus 120 times to the yam on farm 2 plus 90 times to the potato on farm 1 plus 80 times to the potato on farm 2. And then for line 12 until 15, it's just like constraint, where based on the question, it just say that yam constraint must be grow at least 7,000 kgs of yam, and potato constraint just like must from the question it say that must grow at least 11,000 kgs of potato, and length limit like each farm only has 100 acres. So like it mean yam plus potato must be less than equal to 100 on each farm. And line 17 is just that I want to solve the optimization problem for all the variable to minimize cost while like satisfying all constraint that given. And then line 19 until 24 is where I want to display the result, where LP status is just like I want to show whether a solution was found, and dot var value is that to show how many acres to plant for each crop on each farm. And then P dot value is just like I want to show the minimum cost. So like this is the result that we got from the Python coding, where the status is optimal. And then on yam farm 2 acre is 10.77, and yam potato farm 1 acre is 27.5, and minimum total cost is RM 3,767 ringgit point 31 cents. Yeah. And after that, after I use Python coding, I use SI solver in order to determine either my Python coding is like correct or not. So I use Excel solver where as we can see, I just input all the like decision variable, objective function, and also constraint in the Excel solver. And then like here is what I got. And as we can see, for x2 we got 10.77, y1 we got 27.5, and z equal to 3,767 ringgit point 31 cents. So which mean like it is valid with what Python coding that I got just now. Okay, so this is my answer report that I got from the Excel solver. Then this also the sensitivity report that I got from the Excel solver. Last but not least, this is the limits report that I got from the Excel solver too. So the conclusion that I can make for question number 2 is that after solving the linear programming problem by using Python coding and also Excel solver, the best planting plan for Encik Ahmad to minimize the cost is by plant all the 27.5 acre of potato on farm 1 and plant all 10.77 acre of yam on farm 2, and then like these plants meet the exact demand of 11,000 kgs of potato and 7,000 kgs of yam while staying within the land limit of 100 acre per farm. And like even though farm 1 is more expensive for yam, but its higher yield with 650 kg per acres mean that we need fewer acre to meet the target. And farm 1 is like more suitable for potato because it's offer a good yield at a lower cost. And so with this plan, the total cost is minimized to RM 3,767 ringgit point 31 cents. Thank you.
Okay, so now I want to proceed the presentation, which is question 3. The question is minimum W equal to 2x plus 4y plus 5z plus 3q. The constraint is negative x plus 2y plus 2z is greater than or equal than 40. Second constraint is 3x plus 2z plus q lower than or equal to 100. The next constraint is x minus 2y minus z plus 4q is greater or equal to 50. X, y, z, and q are greater or equal to 0. Okay, first I use the C programming. I use include studio.h, integer main, float x, y, and z, and q, float w, and also best x, best y, best z, and best q, and then minimum w 99999. Then I use the title range around suspected optimal values for all the value which is x, y, z, and q. And then I put the constraint from constraint 1 to constraint 3, and then the objective function. So the next one is I continue the programming, which is find the exact match or closest match to the non-optimum. If x equal to 0 and y equal to 0 and z equal to 20, q equal to 75, and we find the best x, best y, best z, and best q, minimum w. And for the output, we print out the best solution, which is optimal solution found, print x, y, z, and q, and we find the minimum w. So we can get the optimal solution found is x equal to 0, y equal to 0, z equal to 20, q equal to 75, and the minimum w is 152.5. So here's the answer that I got from the Excel solver. The solution is x equal to 0, y equal to 0, z equal to 20, q equal to 17.5, and the minimum z equal to 152.5. And the below one is the limits report. Last but not least, here the sensitivity report that I get from the Excel solver from the question 3, and then the right is the answer report for the question 3. Thank you.
Now, let's go through for the question 4. For 4a, we need to find the optimal solution for the following linear programmings. We need to find the maximum of z equal to 6x1 plus x2 subject to x1 plus x2 less or equal to 5, 2x1 plus x2 less or equal to 6, and and non-negatively x1, x2 greater than 0. For part B, we need to find the new optimal solution. We have the constraint 3x1 plus x2 less or equal to 10, and for C, we need to add the constraint again, but x1 minus x2 greater than 6, and for part D, we need to add the constraint and find a new optimal solution for add x1 plus x2 less or equal to 12 in that linear programming. So for the solution of this question, we use the C programmings. First, in the line 1 to 10, we include the standard input and output for library for printing result. For line 11 to 36, we put the feasibility of the functions. First, we to declare the basic constraints, all the variants and the constraints, and then for line 20, we add the constraint for the different variants. For line 38 to the line 55, we add the 5 predefined points test for find the feasibility, and we store the description of each linear programming in the line 50. For line 57 to the line 83, in the line 48, we iterate through the 4 linear programming variants, and then we evaluate each candidate's point for find the feasibility. And then for line 75, we determine the optimal solution for each variance, print the result, and construct the format. For this, we use loop to find the feasibility of the point. And the last one, we put the command for printing to display our feasibility status of each candidates, and we identify the optimal solution. For this, we use if feasible is found, we print the optimal solutions, and else the linear programming is infeasible under these constraints. That's all for this programming, and we go to out the result of this. For the result, we can see in the variance A, we find the optimal solution x1 equal to 3, x2 equal to 0, and z equal to 18. For B, we find the x1 equal to 3 again, x2 equal to 0, z for 18. But for C and D, the linear programming is invisible under these constraints. Same goes to the D. After that, we recheck the result of the programming in the Excel solver. We can see here A and B giving a same answer as the result of the programming, which is x equal to 3, x1 equal to 0, and z equal to 18. Now, let's go to C and D. After we check with Excel solver, we find out the problem is infeasible. It shows the programming is right because A, B, C, and D answer are same as the result of the programmings. That's all for the question 4. Now we can move on to question 5.
Next, for question 5, which is maximum z is equals to 4x1 plus 5x2, and such that 3x1 plus 2x2 is less or equal than 10, and x1 plus 4x2 less or equal than 11, and the last constraint is 3x1 plus 3x2 less or equal than 13, and the sign restriction is x1 and x2 are greater or equals to 0 and integer. Next, for question 5, this is the coding for the question 5 using Python. So first, from line 1 to line 3, we import necessary libraries such as Ortho Linear Solver, Matplotlib, and also NumPy.
Our tools is used to create and solve optimization problem, while Matplotlib is to draw a graph and visualize the results. And NumPy is used for handling numbers arrays or helps with math function. So next is for line 5 to 6, we create a solver, which is we use SCIP, which is a solver that provided to support mixed integer programming. And this line is create a solver instance so we can define our variables, constraint, and also objective function. Next is line 8 to line 10. We define our variable, which is we use two variables, x1 and x2, and we use integer var to make sure that the numbers are integer. And the next one, we put lower bound equals to 0 and upper bound is equals to infinity. Next, line 12 to line 15, we adding our constraint, which is each constraint we add solver.add ... to indicate that the constraint from the problems. And next, from line 17 to line 21, we define our objective function, which is creates an objective functions from the previous questions and tell the solver to maximize it. Next, line 23 to line 35, we solve the problem, whereas we use the commands, runs the optimization solvers and find the best value for x1 and x2. So we use dot solution underscore values. If the solver find the solution, it extract x1 and x2 values. However, for dot value in bracket is to extract optimal solution z, that it prints the results. Next, for the line 37 to 43, it's for visualization, which is to create arrays to draw each constraint line and rearrange to express x1, x2 in terms of x1 for graphing. Next, from line 45 to line 48, we plot the constraint line, whereas we did a command to draw each constraint line using a different colors. Next, for line 50 and 54, it shows the feasible region, and we say whereas this part check all integers points between 0 and 9, and if a point satisfy 3 constraints, it's feasible. And those feasible point is plotted as a black square or prime kx. And next, the last one, for line 56 and 67, it shows the optimal solution and plot a big red dot to point out the optimal point. And we add the axis limit, label, title, legend, and also the grid. And we ask a comment plt.show to display the graph window. So this is the graph that we obtained from the previous coding. So as we can see that the feasible area is plotted using the black square, whereas between region 0, 2 and 2, 0. And we can see that the each constraint is lined using a different color, and also the red dot to point out the optimal solution point. So from the previous coding, we get the output for the optimal solution, where is x1 is equals to 2 and x2 is equal to 2, and the maximization is 18. Next, using the Excels, we transfer our data from the questions into the Excels, whereas for B1 and C1 and also D1, we put our variable, which is x1, x2, and also z, which is objective functions. And for the D2, we put our objective function formula, which is D2 is equals to B3 times B2 plus C3 times C2. And as for the constraint 1, 2, and 3, we also put the formulas from the question, which are D5 is equals to B5 times B2 plus C5 times C2. And for D6 is B6 times B2 plus C6 times C2. And for D7 is B7 times B2 and plus C7 times C2. Then we put our B2 and C2 as our changing variables. And for the left hand side, which is D5 till D7, as the solutions that we need to obtain. Then after putting all the informations or the data inside the Excel, we use the data solver. So for the set the objective, we put the cells D2 and we're choosing the max LP, and by the changing variables is B2 and also C2, and we put the subjects to the constraint, which is D5 is less or equal than 10, D6 less or equal than 11, and D7 is less or equal than 13. Then we put the changing variables B2 and C2 as integer, and B2 and C2 into C2 are greater or equals to 0. Since this question is in the integer and sign restrictions are x1, x2 are greater or equals to 0 and integer. After that, we obtain our solution, which is for x we got 2, and for y is equal to 2, and for the optimal value is 18, while the left hand side is for constraint 1 is 10, constraint 2 is 10, and constraint 3 is 12. Next, as you can see from the answer report, we obtain our final value is 18, and for the variable cells for x and y are both 2, we obtain the value is 2, and this satisfies all three constraints where only the first constraint is binding, and the cell as let variable shows that some resources are not fully used in the constraint 2 and 3, and also both variables are integers, and therefore this Excel output validate or have the same solution as the coding previously.
Now I'm going to explain the last question. So the question is maths z equal to 5x1 plus 6x2 plus 7x3 subject to 9x1 plus 12x2 plus 5x3 less than or equal to 40, 6x1 plus 4x2 plus 5x3 less than or equal to 30. So x1, x2, x3 greater than or equal to 0 and integer. I solved this question using C programming. You can see the coding and I'm going to explain the coding line by line. So for line 1 is to enable function like printf and scanf for input or output. Line 2 is to provide memory management utilities. Line 3 is to allow use of round for integer conversion. Line 5 until 8 math sets an upper limit on variable and constraint. A represent the coefficient of constraint, B is for right hand side values of constraint, and C is for objective function coefficient. For line 11 until 14, the function of coding is to check if a value is integer using absolute difference. Next, the function of coding at line 16 until 21 is to check if solution is integer feasible using loops. If any variable is not an integer, returns 0, otherwise returns 1, which is true. For line 24 until 37 simplex algorithm, the coding is to find entering variable by locating the most positive coefficient in the objective row, and if no positive coefficient exists, the optimal solution is reached. For line 40 until 54 is to determine pivot row using the minimum ratio test. If no valid row exists, the solution is unbounded. Line 57 until 70 is to perform the pivot operation to update constraint coefficient, divide pivot row values by the pivot element, and eliminates column value above and below the pivot row. Next, move to line 73 and 83. Display integer solution by rounding variable to integers. Display result for x1, x2, x3 and computes the maximized integer z. Line 86 until 90 is about main function. It collects user input for number of variable and constraint. Line 92 until 95 is to read constraint coefficient A matrix. Line 97 until 99 is to read values for V vector representing constraint limit. Line 101 until 103 is to read coefficient for objective function. And the last one is to run the integer simplex method and output the final integer solution. When you run the coding, you need to put the value based on what it wants. Then the output will be displayed like this. Therefore, the optimal solution is x1 equal to x2 equal to 0, x3 equal to 6, and z equal to 42. Next, we also can solve this question using Excel server. You need to put the value of objective function and constraint in Excel, then click the button solve. Therefore,
This is the optimal solution. The optimal solution is obtained as follows, where x1, x2 equal to 0, x3 equal to 6, and z equal to 42.